So what we're just talking about now is I still need that bank.
So imagine that you have they each have but they weren't, but one of them is your based on
What is going on with this thing?
You can get into this problem totally with the account, even though the transaction itself is verified between 20 and multiple pages.
Okay, thanks everybody. We're trying to start the seminar. Those of you people who don't know me, I'm Gareth Wood. I'm going to chair the IT. Thank you very much. Tonight we have a very interesting program. Grand Lodgement with the Air. Merci. Welcome. I'd like to do a bit of a roll call as well for IT members and non-IT members and general guests. So if I could have a show of hands for IT members first, please. Thank you.
It's recorded.
For PEO, anybody from PEO? Thank you. Very much. Anybody from IEEE? And general guests? Thank you very much and welcome.
If you don't know it, that's fine. Welcome.
Yeah, thank you very much for coming tonight. I would like to continue and introduce you to Grant. Thank you very much for putting this on tonight. I'll put it into your capable hands.
Thank you. Honored to be asked. I'm just wondering if we can turn down the lights a little bit so the contrast is better for.
Did you want me to do a quick intro to?
If you could.
Okay, I'll do that.
I've got a little intro section on there as well. So.
But I'll just set the stage a little bit.
Sure.
My name's Edward Morton. I've been hanging around the local network for some time. Right now I spend quite a bit of my time in jail. I work for Correctional Service Canada, and I'm part of the team that's put together a long-term vision for the environment, the electronic security systems environment at Correctional Service Canada. And interestingly enough, Grant picked up on this material, this approach, which is essentially objectifying everything, IP to the edge, a full command and control environment, and he ended up working with and convincing an outfit in the States, one of the biggest players in the detention lock marketplace, Southern Folger, a merger between Southern Steel and Folger Adams, to go IP to the edge. And over the last few years, a couple of years in fact, we've been working with Grant and some of the Southern Folger folks, and Correctional Service Canada is actually doing some trials of what I think you're going to see here later on this year in Collins Bay. I thought it would be very interesting now that this technology is, should we say, out of the bag, to have Grant talk to us about it. So without further ado, I'll put you in taking the lead here. We will really spend a lot of time enjoying as well.
Yes.
And we'll go from there. Grant?
Thanks. I think everything's working. I haven't rehearsed this through. I did one that was 30 minutes a couple weeks ago, so I'll try to meter it out. I would like to spend the first half of it just going through the process, which was as much a project management challenge as it was a technical challenge. But then I have a live demonstration of the lock itself. So just curious, how many of you have ever toured a prison, been in prison? Don't need to know why. Okay.
Parole officer, so it's possible.
It's on a need-to-know basis, right? So I feel bad for my girls because Father-Daughter Day at school is always interesting. When I tell their class I've been in and out of prison for 30 years. So I did go through the electrical engineering program in Saskatchewan. I'm a former Flatlander, so I spent a lot of my career out west, but in a suitcase to various parts of the world doing automation systems. One of the first jobs I had as an automation engineer was putting in a touch screen system to control a prison. And I had no idea at the time that this would haunt me through my career, because it was a first of in Saskatchewan for sure. And I didn't revisit any prison systems for many years later, after having deployed a lot of automation and control systems in the pulp and paper patches, in oil and gas. I was up in Alaska. I was in Egypt for a while doing some automation work on a large SCADA system in the Delta. But in 1994, I was working for a manufacturing company in the prairies, and there was a real need to get not IP at the edge at the time, though that was coming very shortly back in 1994, but having smarts out in the field. So in the automation industry, smart sensors, they started up around the mid-90s, and there were a number of protocols, a number of means to communicate to these sensors that all of the big global companies were competing with for space. Ethernet was not deemed reliable at the time. It was not deterministic enough, too many collisions. So they had purpose-built communications. The one I happened to springboard back then was called DeviceNet, which was led by Rockwell Automation. And it was a means to communicate to field devices. So they were looking at the automotive industry that was using a network backbone to pipeline to smart sensors in cars, and they started applying it into factories and industry and plants. And they were deploying their own field bus networks. They were called DeviceNet, HART protocol. So they're still in existence to this day. Ethernet came about around 1995, and as it grew and became more mature for automation, it began becoming deployed in the physical security industry. But if I look at the industry on the whole, it seems like physical security industry has been about a decade behind the automation industry in terms of deploying some of these. And it could be twofold, could be the economics of it, the budgets, but it could also be the security resilience that's required in some of these locations. So I was asked, I started up my own company. I was about 34 years old. I was out in the prairies, and I started up my own automation company, and I was asked at the time by Corrections Canada to do some prototypes of the technology we were using in automation. They wanted that deployed in a correctional facility to see how it would work. I was using off-the-shelf equipment, off-the-shelf software, and there were many benefits to that from a service standpoint. There were many more students coming out of colleges trained on that technology. They had an experience of using proprietary security equipment by Honeywell, Johnson Controls, and it was very difficult and expensive to have this equipment updated. So I did some test systems for them out west. It went well, and pretty soon we were doing several systems out west, and we grew the company across Canada. And there was about 60 people nationwide, and I sold my shares back in around 2011. And not long after, I was still employed with them, but I came up with this idea, which, as Edwin had mentioned, you know, I gleaned from reading one of his white papers. He was taking the corrections security systems and the complete backbone to IP at the edge and trying to develop a more horizontal, ubiquitous architecture, more plug and play for the corrections environment. So I got my brain to thinking about it, and I flashed back all the way to 1987 when I did my first door control system for a prison. These are the locks that you'll find in the prisons. Heavy gauge steel, they're more a machine than they are a lock. So basically with prisons, you're keeping people in instead of regular security systems where you're keeping people out. So the amount of infrastructure you need to do that it's much more comprehensive. These locks have been around a couple decades, 25 years. You'll see them in facilities around the world. The company that makes these is Southern Folger. They've been around for 100 years, more than 100 years, and they have about 85% of the global market share. If you'd told me in 1987 that in 30 years it would be identical technology and it would be the same controllers, PLCs they're called, controlling these, I probably wouldn't believe you. I couldn't understand why there'd be no change. So the owners of Southern Folger, they're quite progressive, and but in terms of locks, I mean, the sell is, how do you convince owners that have locks that are working for 25 years to cut them out? They have service issues with them, obviously, but unless the manufacturer is going to lead the way with innovation, it just wasn't going to happen because the customers weren't screaming for it in their face. So there was a number of stars that had to align to even make the project happen, a lot of which didn't have much to do with engineering and more to do with old-fashioned sales and strategy. So I did work with Corrections Canada and Edwin to validate the concept. I pulled together a team of Canadian engineers, and I pulled together a budget to develop a smart lock. So the intention was to put embedded controls in the lock, make it PoE, power over Ethernet capable. So we just have to run one single cable to it. And take advantage of having the computing power at the edge. So it's a nice feature to have Ethernet connectivity, but if you're going to have a processor out in the field, just like I experienced with smart valves, smart transmitters in automation in the 90s, where they were putting a lot of intelligence in devices and having error correction and maintenance features in them, I thought we should do the same with this detention lock. So I'll show you a number of those features as we progress here.
I'm not really clear on what problem you were solving, though. What was the lack exactly? Like, what were they missing that you were solving?
The problem with the existing system, I'll demonstrate in a few slides here. You had just a very few handful of contractors that understand this black art of PLC programming. Okay? So you're basically at their mercy to come in and work on the locks, repair them. The large security companies don't play in this space because it is specialized. You have an investment, and if I go back and look at at a higher level, it has to do with the total life cycle cost of the assets you're putting in the facility. So with the current systems, you're investing in hundreds of thousands of dollars in this control equipment, and this control equipment is in a centralized, environmentally controlled electronics room. So you have to have the real estate for that equipment, you have to have the cooling, and now to go from that equipment out to the lock, you're not looking at a single cable. So you're looking at 6 to 9 conductors just for the control wiring. And anything could go wrong with terminating those 6 to 9 conductors. And when you have hundreds of locks in a facility, the time to commission and test it goes up quite a bit. You also require, in many cases, a second run of cable in a separate conduit system for power. And when we're talking about a facility that's steel and stone, and you're coring conduit into these facilities, we looked at a 500-bed facility and we figured one run of conduit to all of the cells was at least $500,000 savings. Yeah.
Big saving in construction costs.
So that's, yeah, the construction cost reduces life cycle costs. We've been seeing all the past generation, they're just used to using mobile platforms, computing platforms. They need to get to the information quicker, easier. Data mining's become a thing, Internet of Things. So there was just no way to do that with the current technology that had been stagnant for 30 years. So when we looked at the particular case with Corrections Canada, they're very similar to other national organizations, be it private or public. In this case, Corrections Canada manages 57 institutions, 16 community correctional centers. And over the several decades, they're upgrading all of these various platforms. They're tendered, so you have different contractors doing different sites. And it ends up with the operators having a different user experience as they move from site to site for the controls of the facility, as well as the maintenance personnel. They're dealing with all manner of different technologies by different vendors. So there was no real consistent platform. There were different solutions to the same problem. There was little or no crossover benefits. There are multiple and proprietary communication protocols. Understand this is going on right now, so part of Edwin's mandate is a path forward to get all of this moved to a more modern, ubiquitous platform. There is little to no intelligence from the field device, and we'll show you the benefits of moving intelligence to the field with these locks with the demonstration. Cumbersome forklift upgrades, so if you wanted to upgrade systems, you're basically sole sourcing in many cases, to the original contractor that did the base work. Demanding end user environment and ongoing technology life cycle replacement costs. So that was part of what Edwin inherited in his landscape. And he prepared a white paper he presented at the Carnahan conference in 2010, I believe it was, 7 years ago. I read it in 2011, tried to gain some traction on this idea in 2012, and here we are 5 years later. So these developments are quite a process. The drivers that were identified in moving to IP at the edge, as well as a change to the software standards at the head end, was high availability, increased reliability, ease of operation, the ability to integrate new applications more seamlessly. Again, making it simpler, because right now the integration world has a real job cut out for them with all these different products they have to support and communicate with each other seamlessly. Reduce maintenance and training costs, provide more rapid deployment, upgradability, open and competitive procurement, and again, full integration with TCP/IP infrastructure. And until the entire landscape's IP, they still have to deal with integrating with non-TCP/IP devices, such as the locks. If we were to look at I wonder if this is coming up here, just a minute. I'll just skip over this one here. This diagram is very simplified, but it shows at a detention center, the upper half would be the operator's experience, or the service personnel's experience on the user interfaces. The lower half is the field devices. We're seeing the video platforms, video management systems have moved to IP. They started in Corrections Canada in 2005, migrating all these old analog camera systems to digital. The intercom systems, they've cut over to IP. So rather than having myriads of cable running to all these different systems, we have just blue hose. your Cat 5 or Cat 6 running to these systems. But the good old door control detention hardware was just still sitting here with door relays, panels and panels of terminal blocks and wiring, and PLC equipment that all had to be wired to the door relays. So several points of terminations, any one of which could go wrong, and even after installation they can go wrong. So we look at the new proposal that I presented to Southern Folger was eliminate the PLC and the door relays and cut over the smart locks to PoE. So now we're dealing with a typical network backbone installation, network switches instead of PLCs. You can rely perhaps on more companies and contractors that can support the technology, because you don't have this black art of PLC programming in the equation anymore. When you look at the total amount of devices in a prison detention system, the locks consume a good portion of the amount of devices that go into a facility. So the lion, the lion in the room, they were doing nothing, and all these other industries were moving forward with more advanced technology. This is just a picture showing on the left-hand side PLC panel. It doesn't show the PLCs, just all the wiring involved. And on the right is just blue hose and switches. Very easy to wire. Doesn't require an electrical contractor, which is a huge advantage in many installations. So I pulled together a team of hardware, electronics engineers, chaps that I graduated with from college, and a local software team here. We pulled together a very preliminary budget. It was like a class 4, so plus or minus 50%. A WAG is a term I've heard, wild ass guess. Because we had no idea what the client would want, if he even wanted this. But I had to decide on who to run with for this, and it only made sense to go to Southern Folger because they had 85% market share. And I wasn't interested in creating a detention lock. And the only way to make this product as intelligent as possible was to have it tightly integrated with the machinery that they have in the lock. So I'll just explain Southern Folger. They were established in Texas. Southern Steel was the one company in 1897, Folger Atom in Illinois in 1905. The two companies merged in 2004, which gave them the lion's share of the global market share. And just last spring here, they were acquired by Trustbuilt, which is the world's largest manufacturer of hollow metal frames and doors for prisons. So this company now has the lion's share of the locks and hollow metal and frames, a decided advantage for them on being able to build prisons. When I had met them 4 years ago, they had just come off an R&D project that there was very little cost control. It's very difficult with R&D. How many of you have been involved in R&D projects? And how many of your R&D projects stayed tight to the budget by the end? Right. It's the chicken and the egg. So you're being asked at the start of the R&D, what's it going to cost? Well, we've never built it, so how do I know what it's going to cost? If we build it, then I can tell you what it's going to cost. But the decision makers need to know within some degree of accuracy what it's going to cost, and so you try, and then inevitably it ends up 2-3 times over budget. So we we were very conscious of their experience with R&D by another contractor going into this relationship.